Have you ever wondered how a self-driving car stays perfectly in its lane? Or, how a satellite millions of miles away can point its camera with just pinpoint accuracy right back at Earth? Well, the secret sauce behind all of that is a really fascinating and powerful field. So let's dive into the world of control engineering.
All right, here's our game plan. We're going to journey through 5 key areas. We'll start with the big picture applications. Then we'll zoom right into the core ideas. We'll also look at what it takes to actually become a control engineer, check out the career landscape, and finally, peek into the automated future that this field is building as we speak.
So, first up, what does control engineering actually, control? Turns out, it's the invisible brain behind so much of the technology that basically defines our modern world. It's working silently in the background, making our lives easier, safer, and a whole lot cooler.
Now, what's really amazing here is just the sheer breadth of it all. We are talking about the algorithms that guide autonomous cars and the robotic arms that build them. It's the science that keeps satellites from tumbling through space and our power grids from overloading. It even goes into smart medical tech, like these incredible prosthetics that can respond to a user's thoughts. The scope is it's massive.
Okay, so we've seen where it's used, which is pretty much everywhere. But let's get into the how. What are the fundamental ideas that make all those incredible applications even possible? This is where we get into the art and science of control itself.
At its heart, control engineering is kind of like being the conductor of a high-tech orchestra. You're not playing a single instrument, but you're using your knowledge to make sure every single part of the system works together in perfect harmony. Whether the goal is maximizing speed, making sure something is insanely accurate, or boosting efficiency, it's all about managing a system's performance.
And this is huge. It shows you the key distinction in all of control theory. On one side, you've got an open-loop system. Think of a simple toaster. You set the time and just hope for the best, right? There's no feedback. But on the other side, you have a closed-loop system, which is constantly checking its own work. An aircraft's autopilot doesn't just point the plane in a direction and call it a day. No way. It's continuously measuring its position and making thousands of tiny adjustments to stay perfectly on track. That feedback loop is the absolute secret sauce. It's what lets a system self-correct and adapt.
So you might be thinking, what does it take to become an expert in this? What kind of person builds these systems? Let's take a look at what goes into building a control engineer and what's in their toolkit.
Yeah, no surprise here. It all starts with a rock-solid foundation. This is definitely not a field for guesswork. Success depends on a really deep, almost intuitive command of math, physics, and programming. These are the languages you use to describe and predict how incredibly complex systems are going to behave in the real world. They're totally non-negotiable.
And building on that foundation, students dive into some seriously specialized courses. Just look at these titles. Dynamic Systems and System Identification is all about figuring out how things change over time. Adaptive and nonlinear control, that's for systems that are super unpredictable. The whole curriculum is designed to create engineers who can analyze and manage systems of all kinds, from the really simple to the wildly complex.
Of course, all that theory needs tools to make it real. You can't just do this with a pen and paper. Modern control engineers are absolute wizards with powerful software. MATLAB and Simulink are the industry workhorses for modeling and simulating everything. Then you've got tools like Python and PLC software for actually implementing these control systems in the real world, in everything from a robot to a power plant. And just to put this into perspective, an undergraduate degree in this field typically means around 120 credit units. That's a lot of work. It's a really rigorous program, but it's designed to produce these highly skilled problem solvers who are ready to take on the biggest challenges out there.
Okay, so you've put in all that work. You've mastered the math. Now what? Where does all this training lead? Let's explore the career outcomes and see what it really means to have a professional life where you are in command.
The career paths are just as diverse as the applications we saw at the beginning. Remember those autonomous cars? That's a smart systems or EV engineer. Those robotic arms in the factories? That's a robotics engineer. It's a skill set that is in ridiculously high demand across the entire tech landscape, and you can see why.
So where does control engineering fit into the big family of electrical engineering? Well, think of it like this. If a power engineer builds the engine of a car, and a telecom engineer builds its communication system, the control engineer is the one designing the cruise control, the stability systems, all the things that actually manage how the car behaves. Their unique focus is on dynamic performance. They make things move, react, and adapt just right.
But let's be real, what's the day-to-day actually like? Well, like any high-level profession, there are trade-offs. The advantages are huge. Tons of job opportunities, great salaries, and really satisfying work on the cutting edge of tech. But the flip side is that it's demanding. The workload can be high, it requires some serious analytical chops, and you absolutely have to be a lifelong learner just to keep up.
And that brings us to our final section. Control engineering is not a static field. Not at all. It's constantly evolving. So let's look ahead, see where it's all going, and what the future of automation really holds.
For those who really want to push the boundaries, advanced degrees open up some truly mind-bending research. This is where science fiction becomes reality. Seriously, we're talking about systems that can learn and adapt all on their own, thanks to the merger of control theory with artificial intelligence. This is the frontier of the Internet of Things, of next-generation robotics, and it's all happening right now. You know, this quote from our source material really just nails it. A combination of theoretical knowledge and practical skills, offering wide-ranging career and research opportunities across multiple industries. It's that blend of theory and practice that unlocks this incredible range of opportunities to actually shape the future. And that's what makes this field so exciting.
So, I want to leave you with a question to think about. As all this technology becomes more and more a part of our daily lives, from our homes to our cars to our cities, what is the one system in your life that you just wish had smarter, more adaptive, more intelligent control? It's a fun question to think about, and the possibilities are pretty much endless.